Hello, ladies and gentlemen, and welcome to the Sethiya official game show. Today, our contestants are Cash Thompson and Braga Shrivenissen.
It's truly awesome.
I don't care. Whoever wins this game gets $10 and a free vacation to the Gulag. All expenses paid. Now, first question. How does hit the ball demonstrate Newton's first law? If you don't know, an object at rest remains at rest, and an object in motion remains in motion at a constant speed and in a constant straight line, unless acted upon by an unbalanced force. And that is Newton's first law.
But because it's cool.
Get out.
Wait! I think it's because the lever does not move unless acted upon by the hammer, which is an unbalanced force. This lever only stops moving due to the friction of the cardboard and the pole stopping it from going forever.
And that is correct. Congratulations.
Yay.
You have won 1 point, my good.
I'm up a point right now. I don't think this competition, Rogov, is going to be able to come back. I'll be in the gulag in minutes.
Wow, this game show is so cool. I wonder who's gonna win.
And now to our commercial break.
Velocity is essentially the same thing as speed, but instead of using distance, we use displacement. Displacement is the identity of how far an object is from where it started, instead of how far it traveled. So, for example, if this hammer started here, moved over here, and came back, while it would technically have a distance of 2 units of traveling this way, it technically has a displacement of 0 because it didn't travel at all. Velocity also has direction as a part of it. So, for example, if a hammer is dropped like this, it has a velocity of 2.4 meters per second down, but when I move it up like this, it has a velocity of 2.4 meters per second up, meaning they do have different velocities. Acceleration is the change in velocity or speed over a certain amount of time. For example, this hammer is accelerating. This is because it starts out at a velocity of 0 meters per second because it's standing still, but near the bottom, it's traveling at a much faster velocity, around 2.4 meters per second. This shows that it's accelerated 2.4 meters per second over a certain amount of time. Say that it took a second for it to travel down, that means it's accelerating at a rate of 2.4 meters over second squared. Since we've already calculated velocity, speed is an easy task. There's no difference in displacement and distance when the hammer moves, so we can just remove the magnitude and get a speed of 2.4 meters per second. The force that the hammer carries is 1.14 newtons. This is because the hammer gains 2.4 meters per second in velocity in 0.4 seconds, meaning that the acceleration is 6 meters over second squared. Since F equals to ma and the mass of the hammer is 0.19 kgs, we can easily see that the force must be 1.4 newtons. This game shows balanced and unbalanced forces because the platform is balanced until the hammer hits it. The hammer acts on the platform with an extra force that can cause the platform to become unbalanced, causing one side of it to launch upwards. The potential energy of the hammer before it is dropped is 1.86 joules. Potential energy is equal to mass times gravity times height, and we already know the gravity because it's always 9.8 meters over second on Earth. And in addition to this, in our previous calculations, we know that the height of the hammer is at 1 meter and it has a mass of 0.19 kilograms, so it is trivial to see that it has 1.86 joules. The kinetic energy of the hammer before it is dropped is 0.55 joules. The kinetic energy is equal to 1/2 mass times velocity squared, and we already know the velocity at the end was 2.4 meters over second. In addition to this, we know that the mass of the hammer is 0.19 kilograms, so it is trivial to see that the amount of joules is 0.55. The law of conservation of energy is present in our game as potential energy and kinetic energy constantly exchange energy. When the hammer is raised and held still, it has a velocity of 0, meaning its kinetic energy is 0, but that's when it has the highest potential energy due to its height. When the hammer is close to hitting the platform, it has the highest velocity of 2.4 meters over second, and therefore the highest kinetic energy, but it's also at the lowest height and therefore has the lowest potential energy.
How does this game represent Newton's second law? For those who don't know, Newton's second law is that force is based on how much mass an object has and how fast it is accelerating. This is why larger objects have more force and why the harder and therefore faster you kick someone, the more it will hurt.
It's because the more you accelerate the hammer, the further the object goes.
Correct! You have won a ball.
When I got kicked out of the first round, I was doubting my chances. But after this comeback, I do think I can do this. Never back down, never what? Never back down, never what? Never give
Last
up.
question. How does hit the ball demonstrate Newton's third law?
Because the platform is reacting in the opposite direction, causing it to take work to hit the platform and launch the ball out.
Well, that was real close. We'll have to check the footage for that one.
That was all me. I'm sure I'm gonna win this one.
Are you kidding me? That guy was a full second slower than me.
Now, because no one won, I think I get to get the prize and go to the gulag.